Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, we're gonna take a look at the updated version of Sverchok TEXTURE VIEWER node. So, if you look at the nodes now, you can see that this node slightly has more options, and you can output 5 different size of image, and you have this 3 different color mode. Black and white, which is a single channel, and then RGB and RGBA, which is like 4 channels. So lots more options. That means lots more possibilities, and also can be can be a little bit slightly more complicated, but it depends how you do it. Let's just save it first. Texture viewer update. So if we use like random vector, for example, random vector generator is will generate like 3 values, which is this random value in X, Y, Z. But remember that we are dealing with RGB, and with RGB, normally you don't want to have negative value. So keep that in mind all the time. But you can use this value and kind of separate it into RGB just simply using vector out. So if we do that, separating the XYZ for the RGB, and if we switch this to black and white, we already know that we can see the value here. I think S is actually 128 by 128 pixel. Let's try a smaller value first, 64 by 64, but you can see there's also this custom texture here. We can try like 10 pixel, for example, 10 by 10, and yeah, it's a bit small, but you can always have it like this. I wish there's a way to scale this. Maybe make it 100 by 100, for example. Okay, now we can see a little bit better. And 100 by 100 means 10,000 value for each of the RGB. So you can see this is 3 value, red, green, blue, as a separate channel. But if you merge them together, RGB, you can see if you plug this guy in, and we have the noise. Our noise looks like that. That's a remember, this is like 10,000 pixels and 100 by 100 pixels in size. So always keep that in mind. That's actually pretty big, even though these days you are dealing like with 1K, 2K, and your smartphone can take like 4, 8, even 12 megapixel or even higher. So, but in terms of computer size, actually this extra large can do like 1024 by 1024 pixels, which is actually pretty big, and it can take like a few seconds to process. So whatever value you plug into this guy, you can now separate the channel or kind of mix them together as a RGB or RGBA. So that's really interesting. Let's see. Currently, we don't actually have a way to export out image sequence. However, you can specify like a single image where you want to save it. For example, I'm saving this out into the desktop, for example, and name it like noise RGB, and then this is the file format. I'll leave it at PNG and save, and it should give me the noise RGB. Okay, so that's the results. That's 100 by 100 pixel. Very nice. You're able to do this now inside Sverchok. It's quite interesting. It's almost like a compositing, or even like sometimes it's a bit like a cycles material node 3, but this is more like a compositing. So you can do image processing using Sverchok, and you can actually plug in anything, even like if you want to see the monkey and how it looks like. I'll save this. Let's say you have the monkey, right? The monkey have all how many points of the monkey? You have 507 vertices, and you can plug that 507 vertices into this image just simply by using objects in and get the selection Suzanne, and you know the vertices has point position, and you can just plug that in there, and then you can see this is Suzanne. This is actually all the vector that's made up Suzanne, but you see a lot of black. That's because Suzanne, if you think about the point positions, it definitely has negative values, so you want to probably do some kind of remapping or vector normalize, maybe, I don't know. I think normalize should kind of fix this, or actually not, maybe vector out and remapping, vector in. Let's remap the value. So we should have a value. I'm not sure if Suzanne fits into the bounding box, but let's say we just I'm gonna do it like this. So for Suzanne position in XYZ, we want to turn it into an image, and this should be how it looks like. If we make this yeah, I think we need to normalize the value somehow. 0 to 1, 0 to 1, and 0 to 1. And also, let's say the bounding box is actually between -1 and 1 for Suzanne position. And if we look at it properly, that's actually all the vector that's made up Suzanne, but they are now like a RGB pixel. And if we actually export it out, save this as Suzanne RGB, save. Let's have a look. Suzanne RGB. So that's how it looks like. Yeah, that's a normalized Suzanne position, and every position comes into Sverchok as a list, and then that's why, and you can actually kind of transferring the XYZ into the RGB as a pixel, as a two-dimensional pixel. This is probably a little bit strange at first, but after a while, this actually kind of makes sense. There's actually a better way to kind of think about image processing inside Sverchok. Let me think. You can actually use the object ID get, and there's this option for the images and filter, object ID filter. Let's try to open an image, and I think I have this Mario Peach image. This is, I know that this is a 64 by 64 pixel. You can see from the X and Y at the bottom left there. So it's 64 and 64 pixel, and it doesn't have alpha, but I know that the image comes into Blender as a 4-channel, RGB and A for the alpha. So we need to keep that in mind. So I'm gonna try to load this using Sverchok. This is actually the hard way to do it. There is actually, Sverchok has image, decompose, and image. This is, they're kind of like, they can load image, but they are also a little bit hard to use. They are actually very specialized. You can't get the RGBA right away from these guys, unless, and you need to provide some values, and I'm not gonna go into that again. I think I have live noding that's actually talking about these two nodes. Let's do it this way. This is actually just a little bit harder. However, you will see that if you understand how to use this, it's can be interesting. So the first node here, object ID gets all the image in the current blend files. There's apparently 3 images, but I just want to have pitch. We have Suzanne RGB and we have noise RGB. We just want to use pitch. So that's why I'm filtering the image. Object ID filter. Filter just get one image that's with pitch.png as a name. And now we pipe into this guy, object ID set mk2. This is actually, with this node, we can get into the attributes. In this case, the pixel value. Each pixel has a RGBA value, so RGBA. And we actually have, how many? So if we use a math node, integer and math, how many? This is pitch 64 by 64, and we multiply it. Stethoscope. We have 4096 pixels, and this guy, this pixel size, we need to multiply it again by 4 because we have RGBA color. So we have 16384 values inside a list that's actually coming out from this guy. If you want to see how it looks like, you use the stethoscope mk2 and then check the data and graphical. See, tuple of 16384. That's exactly the value that we have just from this 64 by 64 pitch image. So imagine that. So in order to make this work, to pipe this guy into that guy, we actually, I believe we can just do it like that and specify 64 by 64. So we have pitch image, but if you want to separate it, this can be slightly tricky. So like I said, these pixels, there are actually 16,384 pixels, and everything is inside a list, and the value is that comes as a tuple. Actually, the value doesn't come as a tuple. If I show you with a text viewer, plug this into that guy and view, you can see that this is all the values. It comes as a list. It doesn't have any split for every RGBA. This is like all coming as a single list, and we don't want that. We want to separate the RGBA. For that, we need to use list split. I think list split, yep, and plug in the data here, and the output hopefully is if we split it 4 times, it should be RGBA. So now it's correct. It's more correct. RGBA 0001 0001. So this is now, it's good, and we can actually, I believe we can use color out, or actually color in. No, it's actually color out. With this value being split, we can separate it into RGBA, use the alpha, and hopefully, fingers crossed, this actually works. And now indeed this is actually working for us. So we have the RGB, and the alpha is actually white because it doesn't have any transparency on this image. Okay, cool. We can separate the RGB. Now this is almost like Blender image compositing, because now we can kind of play around with the RGB. Let's say using vector in, we can switch the RGB around, or we can also use the color in, I believe. So with color in and RGB, if we switch to RGBA here, switch the red to green to red, blue to blue, and we get we should get an image. There you go. I need to use alpha. So yeah, there's always something to keep in mind. We are actually dealing with 4 values, RGB and sometimes with A. If you actually just want to use the vector, you can also do that. If we just simply use this RGB, so XYZ correspond to RGB. So instead of using color in, we can use vector in. I think with color in, we can actually switch this to HSV as well. So that will be a little bit strange, but yeah, you have that options. With RGB coming into this guy as XYZ, we can actually use vector, maybe vector fractal, plug this guy in there, and then the value out in there, and we get another interesting result. So yeah, there's a lot of option here. So, but you just need to be careful how many channel you're dealing with. So this is 3 channel becoming a single scalar value. So that's why you're only using the BW. But if you are using something like vector noise, so another functions that usually you use with a point position. Now if you plug the RGB into this guy and you have the noise output, you can plug into this as RGB, and again you have another interesting result. So almost like I think this is like pitch RGB goes into the noise, so you have kind of like a random looking pitch now. There is no way to scale this at the moment, but you can output this out. I don't know it yet if you can save or scale the image. Maybe there is a way to do that properly. But for now, just for simplicity, I'll try to save this as pitch noise and save it as, let's try RGB for this guy. Save it into the desktop, save, and we should hopefully get pitch noise. Oh yeah, this guy. Set the result. Yep. Try it again. Save it again. Save. And there you go. That's pitch noise. And yeah, we really have a lot of control here. It's actually not easy. I know it's not so easy to understand because we are really separating the values of each pixel of this image, and this guy is maybe a little bit cryptic, but this is basically get all the image and then filter it out, filter an image with name pitch, and then get all the pixels as a list, split the list into RGBA, that's why we specify 4, and then based on that we can color out the image because they are already like a split it into different channel, and you can then remix it back, or you can play around with the vector. So yeah, it's a little bit complicated, but the cool thing is that you can now have access to every single pixel value, and then you can also modify the value as you please, and this is really powerful. If you are using Python scripting, there is Python actually have a module called PIL, or Python image. I don't know what is PIL, what does PIL stands for, but Python has a way to deal with pixel, and in fact lots of data visualizations kind of deals with pixel of an image, and because image processing is kind of like a big subject, and you definitely, if you understand this is just like the basic, but the fact that you are able to access each and every pixel value, and of course you can modify that value in whatever way you like. And in order to do that, you probably want to use a scripted node in the Sverchok. Yep, a little bit complicated, but it's a lot of possibilities here. So yeah, so I guess that's pretty much it for this live noding video. If you have any question, feedback, suggestion, let me know in the comment section below. I'll see you in the next video. Thank you.